Hello there, welcome to today's live webinar on the latest release of XPSWM and XPSTORM 2017.1. My name's Sophia Buchanan and I'm the Water Resources Engineer here in our Brisbane office. We're also joined by Tony Cooch, who's our product owner from the Portland office, who I'll introduce a little bit later on. So moving on, a little bit about XP Solutions for those that don't know us or don't know a lot about us. We've actually been around for 40 years, providing software to assist engineering solutions in pretty much everything water, so stormwater, sewer, overland flows. We strive to lead the industry in customer service and support, and we do this by running these kind of webinars to try and educate users and to help them succeed in their own work. So as I said, I'm joined with Tony Cooch, all the way from the Portland office, and I'm really pleased to introduce him as our presenter today. Tony's got 23 years experience working in XP, and he's the product owner and the absolute gun when it comes to XPSWM and XPSTORM. There hasn't been a single question that I've asked him that he hasn't been able to answer. So Tony's going to run through all the developments in 2017.1, and over to you, Tony.
Thanks so much, Sophia. Hopefully I'll do a little better with my presentation than advancing the slide while you were doing the introduction. Anyway, thanks for that great introduction. So, yes, I'm from the Portland, Oregon office, but I happen to be located in Tampa, Florida today. I am a little bit of a world traveler and I'm about to start a golfing vacation. So it's my pleasure to be with you today, and let me tell you a little bit about the agenda I've got on in store. So I'm going to start by presenting the software using its productivity tools. I want to highlight for you the efficient workflow for building stormwater models. This is applicable to XPSWM and XPSTORM. I'm not necessarily going into any kind of sanitary sewer modeling, which would maybe separate the two products, but as many of you know, the XPSWM and XPSTORM share the same code base and can share databases, and as far as 1D and 2D stormwater modeling, the products are equivalent. I'm going to, along the way in that presentation of building a model, I'm going to be talking about some of the new features and software improvements that we've made for this major release of 2017.1. And I'm going to finish my presentation today with a small discussion about templates, as the templates is one of the tools that I've used to make this efficient workflow. In fact, I've given myself a challenge, and the challenge is that I'm going to build a stormwater model in 10 minutes. I'm going to accomplish this, well, I'm going to attempt to accomplish it, by using a template to start my modeling, by switching to what's called a sanitary or 1D mode in the software. This is new to 2017.1, and it changes the interface somewhat so that it's more customized and doesn't give you the clutter that you might have in doing a full 1D, 2D model. And I'm going to be importing data from various sources like GIS, LandXML, Excel, copy and pasting, and so on to get this accomplished in order to try to meet this challenge. And I'm going to use a tool that's, although not new to 2017.1, I believe it was the last major release of 2016, it allows catchments to be associated to nodes by using a tool called catchment drainage, and it will automatically be able to make catchments as standalone objects snap to the appropriate node that they should be draining to. And I'm going to be also getting some of my elevation information from a surface model, a digital terrain model accompanied with my XPSWM. So what do I have? Let me just give you a little bit of a data summary before we start this challenge. I've got an aerial image and it has a world file, and that world file is going to georeference it and make it show up at the right place and give me some scale to my modeling. I have a GIS file, I have digital terrain data in the same coordinate system, and so these things are going to be able to overlap and be on top of each other. I have in GIS, in the same coordinate system again, polygons for my catchments, and the nodes I also have in GIS, which act as the sub-catchment outlet. So these catchments drain to a node, and that node I also have in GIS. Then I've got a template, and my XP template is got things like model defaults in it, various things like profile setup or XP tables, just preloaded with rainfall data. The template really does make building subsequent models much faster because the information that's in the template acts as like seed information for the next model. I've got an Excel file that's got my conduit data, my global storms that I want to be simulating, and it also has a hydrograph that is from off-site that travels through my network. So not necessarily part of the area I'm studying, but it's the pass-through hydrograph that's coming from something upstream, and I have that as well. So I kind of have a question for you. We've got a poll ready. Do you think I can do it in 10 minutes? So Sophia, let's take a poll and let's see what people's consensus is if I can build a model and review results in 10 minutes. An H&H model, hydrology and hydraulics.
I got to say, I just called you a gun at this software, but 10 minutes, that's not much time. I'll be pretty impressed if you can do this.
All right.
All right, let's just get this poll up so everyone can see what's going on and what everyone else thinks you can do.
All righty.
There we go. Well, it looks like most people think you can do it, 6 to 10 minutes.
All right, well, thanks for the encouragement there. All right, so Sophia, once I start the model, then you can start the time. I've got a little bit of a script here that, I'm trying to remind myself what the right steps are in order so I don't get lost. For those of you that are new to the software, don't worry necessarily about trying to remember everything that I'm doing. Of course, there's going to be a recording. I'm going to go a little bit fast, right? I'm not trying to go to the races, but I'm not going to necessarily describe every little step that I'm doing in order for me to get it done in time. And then later on in the webinar, I'm going to be presenting some of the key things, not in any kind of a challenge mode. So that'll be the time that you'll be able to absorb more, but I want you to get a feel for the efficiency of the software. So let me switch over to my XPSWM, and as soon as I start the create from template, you can start the time and then let us know how we're doing.
No worries.
All right, so I'm going to start now by choosing the create from template and choose continue, and I'm going to place the new model here in my webinar folder. And I'm going to use a template that I've prepared, and this template has in it, as I had mentioned, a lot of information like rainfall that I will be using for the project. I'm going to switch now to the sanitary sewer refinements, the wastewater sanitary, which basically turns the software into a 1D mode, which you can see here, the layer control panel contracted, and all of the things that are related to 2D are removed. I'm going to add my background image with a right click, and from my projects folder again, webinar, I'll load my aerial photo, and I'm going to make it partly transparent, easier to see the other objects perhaps on top of those. I'm going to load my model with a DTM, which is part of the topography, with a right click, and I'm going to create my XP10 from an XYZ file. Z file for those of you that speak proper English. And I'm going to change this to perhaps, instead of a fill color, just displaying contours perhaps every 2 meters. Next, I'm going to bring in the catchments from GIS. With a right click, I can import to the various layers, object layers, and I'm going to bring in my catchments. And at this point, I'm not going to bring in any attributes for these objects. I'm just going to bring them in as polygons. And then I'm going to bring in the nodes. And if I right-click on the nodes, I can import from GIS. Bring in the nodes. These are at the same coordinate system, and in this case I'll just use the attribute for the actual node name. I know from experience that only these 3 nodes in the middle are actually part of the simulation of hydrology, so I'll replace those to be the only active nodes. I'm going to use the tool to associate the catchments with their target nodes, with the catchment drainage, and I could, for example, choose that the catchment is associated by being nearest to a vertex, or I could individually perhaps even pick a certain node to be the target for a various catchment. I click the OK button and it will make all the correct assignments for these nodes to go to their targeted, all these subcatchments to go to their targeted nodes. Another tool that I could use, because I have this plan view, is to calculate the catchment drainage. The catchment areas. Now these catchment areas are found based on the size of the polygon and are automatically being associated with the various subcatchment data in the nodes. I know ahead of time that I'm going to want to simulate multiple storms, so I go to the global storms and insert some extra rows. One of the new features in 2017.1 is the ability to simply copy and paste into this dialog. So that's something new, helps it be a little bit quicker. And you can see I've got for zone 3 10, 25, and 100 year return periods with multipliers for the total depth or area under the rainfall curve. Next, I'm going to add the local data that belongs to each of these nodes. For example, if I double click on the catchment, I can see the areas brought in. I could go in now and say, for example, these are on 1% slopes, and you'll notice that the unit hydrograph time area method was already located here for me, and I can put in the time of concentrations and assign any kind of infiltration data. In fact, this is something that you could just copy and paste to other nodes. Let's assign the time area for our second subcatchment and its time of concentration, and then let's go ahead and select the nodes and paste the fact that I was using the Horton infiltration. In fact, if I go to the next catchment and I was going to use a 1% slope for every one of them, I could also copy this and I'll put in my time of concentration here, and that's something else that could be pasted to another node, and I'll paste that here. So by the time I got to this node, I've got most of my data here except my unique time of concentration, which happens to be 35 minutes. I'm going to save my model. I usually save before I solve. Let's see if I've got everything that I need. Oh, I've missed one item, infiltration on node 1A subcatchment number 2. When you copy and paste, it's unique to the catchment number. So that's why that one didn't copy and paste. So I believe we're ready to go now. I'll solve the model, and you'll see it's solving 1 out of 3, 2 out of 3, and 3 out of 3. It treated these global storms as a batch simulation. Now that's something else that we've tackled in the 2017 version. We have a new Solve Manager. The Solve Manager will actually solve each of these simulations at the same time. If you've got a multi-core processor, for example, 8-core computer, you would be able to solve 8 simulations at one time. So that was definitely going to be a big time saver, although obviously doing it twice with you doesn't save any time, but I was able to save some time. So if I was to look at one of these nodes, for example, I can review results, and you can see my 3 different sets of hydrographs. So I'm done the hydrology part now, so let's get to the hydraulics. I'm going to switch to the hydraulics mode, and I'm going to make all of these nodes active, and I'm going to get some data for them. I'm going to choose to generate ground elevations from tin. I'm also going to import through LandXML the hydraulic network. I've got a model network here, LandXML, which brings it in. So in the runoff mode, you won't want to have any of these links active, but you would want to have all of your network active in the hydraulics mode. Let's switch it to solving both the runoff and the hydraulics simultaneously. Excuse me, we're going to need a outfall. Clicking here, a free outfall, and let's copy and paste to the user inflow my offsite hydrograph that passes through. It's here, I can copy, and I'll paste it here and click the OK button. And I believe I am ready to go. So I could be solving this model. There's no errors. Oh, again, I've solved the typical way, which is in a series. But again, the Solve Manager could be used to solve this. So let's resolve with the Solve Manager. And you'll notice that the three simulations are all happening at the same time using different cores of my processor. Finally, let me close these dialogues and show you that I've got results for each of my global storms. Here, I've got a separate set of hydrographs for the links. I have a different dynamic section view for each of these. I could go and pick the various storms, and I could play this, choosing which storm I wanted to play. Now, about this comparison graphically, or perhaps using XP tables in tabular form, the final new feature that I wanted to talk about is that we could look at, for example, the model's output logs. This launched the 10-year because the 10 was being shown. If I had the 100-year, for example, and I show the output logs for the 1D, now I've got the 100-year. A new feature that we've done to the software for 2017.1 is upgraded the Notepad++ to the latest version and placed in it a comparison tool. The comparison tool allows you side by side to look at the model output. For example, I can see 81 millimeters for my 10-year and 180 millimeters for my 100-year. So that was my challenge. Sophia, maybe let me know, how did we do? How many minutes are we?
You're at 9.5. That was pretty quick.
Oh,
Impressive.
Okay. Well, all right. Well, let me slow down the pace a little bit. I do want to talk about some other new features, and I'll just sort of take my time on those. These are, I don't know, a little ancillary or whatever. So let's go to this global storms, and I'll just go down to one storm now for a moment. And I'm going to bring in a branch. So I've got a branch that I want to bring in that joins up with this small network. And I'm going to use, again, LandXML import. I really like that. It's a great exchange between Civil 3D and XP. But there are other Civil programs that read and write LandXML. So I'm going to bring in the branch. So you'll notice I've brought a branch in here. And in fact, I can save these selections of objects. This branch, I could actually select it and store this as a saved view. I'll call this branch. And the rest of the network, or the main part of the network, I don't know, I'll just call it network. So I'm going to select it and save this view and call it network. Now, if you had moved somewhere else in your view, changed your zoom, and you wanted to go back to one of your views, you could restore it. But not only does it restore the limits of the view, it actually resets the set of selected objects. So It's more than just the view, right? It's a view and selection set. So I wanted to have that. So let's look at, well, perhaps let's solve it first. Let's add a little bit of flow to this most upstream node. Maybe I'll put in a constant flow of 1 cubic meter per second. And let's save and solve this. Oh, I'm missing something. Oh, yes. So in my runoff mode, I don't want these objects active at all. They're inactive. So now we'll be able to solve in our hydraulics mode. So we solved that one storm. Of course, you could solve with the solve manager, but there's no advantage one storm versus one storm at a time. And if I was to, for example, review results on, say, the flows, you'll notice this is something new to 2017.1, some of the maintenance that we did. We actually store the first and last points. So here we are at the very beginning of the time series, and here we are at the very end of the time series. So previously you wouldn't get the first or the last timestamp in this simulation, but we actually place that now. Just a little bit of a side note. But I wanted to talk about another great advancement in 2017.1 that's probably pretty keen for the Asia Pacific region, so our Australian users and areas around, and that is a change to the profile plot. So remembering that I have a DTM, you can see the contours here, we now can show the digital terrain surface along with the profile plots of our hydraulic networks. So if I go to Results Profile Plot, I get to see all of my stored views and selection sets. So I'm going to pick both of these, and we're going to be able to place more than one of these on the same page or the same screen, if you will. And there's a tick box now to use that surface data in that profile plot. So I'll click the OK button and click the OK button again, and now you can see I've got more than one plot. Let me expand this a little bit. And there's a combo box to choose between the different plots, but I can move and organize these. I could put one up here, I could change its scale, I can switch to the second one now, and I can move it and just organize these the way that I would want them to appear. So the couple of changes are the ground surface, as you can see here, is appearing rather than a just straight interpolated line between the nodes, and the ability to put multiple on each page. So that takes me to the end of my live demo of new features, but I do want to discuss some of these things in more detail, so let me switch back to my PowerPoint presentation. So as far as enhancements are concerned, some of the things that I used in my challenge, I used the Solve Manager, which was able to save some time by allowing multiple runs to be done in parallel, utilizing other cores in my processor. I showed you the Notepad++ with its compare plugin. I simplified the graphical user interface by clicking the Sanitary mode, which really is probably somewhat misnamed in that it could also say 1D mode, stormwater. The profile plot with its multiple segments. Oh, I skipped this. Let me go back to my, I don't want you to miss this. For example, if I go in and show you this profile from the branch that I created, you'll notice that these have matching inverts. But the convention in some places for stormwater models is to match the crowns. Well, if you select these objects and you go to the Tools menu, we've got the ability in Modify Elevations to both match the crowns or match the inverts. So I'm going to match the crowns and set my node inverts and link inverts to be modified. Click the OK button, and now I can have the crowns matched. Of course, I need to rerun the model to get a new hydraulic grade line for this case, which I could do by pressing solve and making an adjustment for this node's invert since we've moved some of the other conduits. The rule in SWM and STORM is that your node invert must be equal to or less than the lowest connected link invert, and this tool will automatically fix that for me, and I can go and solve and look at the new hydraulic grade line with the matching of the crowns. Here's the profile, and we could play this and you can see what the simulation would look like. Alright, so back to my PowerPoint presentation. So I've shown this in my short demo, and a few other things which are enhancements, which I'm not really going to talk about too much further, except that they were perhaps shown in my live presentation. We can copy and paste into the Global Storms dialog. The first and last points are visible in the hydrographs, and there's grid file support for the binary equivalent of the ASCII file. So you're allowed ASC files for grids and FLT files, float files, for your grids, for your terrain modeling, and for your referencing to 2D models. So both grid and ASCII, sorry, FLT grids and ASCII grids. There were, of course, many other enhancements. Here's some of them. I'm not going to really discuss them in any great detail, but when you install the new version, there's a changes.txt file. It tells you all of the changes that are made to the software, from enhancements through to all of the software maintenance and updates. Now, the Solve Manager is accessed under the Analyze menu, and as I had kind of alluded to, it allows parallel solves. So if you've got multiple processors on your computer or a single processor with multiple cores, it can use your multiple logical and physical cores. So this is really ideal when you think about the scenario manager or the global storms, in that there's a batch of storms to run. And it's really going to be part of the foundation of our Australian Rainfall and Runoff 2016 storm ensembles that we will be releasing this year. So how are we going to go and do, you know, dozens or hundreds of runs in an efficient way? Well, these storm ensembles are going to require, you know, many groups of 10 to be simulated, and so multi-core processor computers are going to be able to do it more quickly. There's two dialogues that pop up with the Solve Manager, one called Solve Manager Dialog and another called the Engine Viewer. It automatically gets populated with the global storms or the scenarios, but you can manually add, delete, and change the order of your solves, and filling out this table above, including selecting if you wanted the double precision or single precision analysis engine. The engine viewer is a little bit of a log of what's happening. Both dialogues are required, so we've had a couple of instances where people have closed their engine viewer and then the Solve Manager won't run. So if you don't like the position of where that dialogue is located, move it off to the side or minimize it. Don't delete it. It looks like we're going to have to prevent people from closing this dialogue without closing this one in the future, maybe in Solve Manager 2.0. Just a little bit of wisdom there that I'm imparting to you. So the Solve Manager really has gone, well, it's advanced us from a consecutive type of approach to a concurrent one, as opposed to solving 1 out of 3, 2 out of 3, 3 out of 3, for example, for a 3 run case. We're now going to have 3 runs of 1 out of 1, you know, all solved at the same time. The next new feature I wanted to talk about would be the Notepad++ edition. So the editor that is used with XP, the text editor, the one that's getting the error logs and messages, etc., is effectively selectable by the user. You can customize this. In the INI file, or application settings, you can get from the tools menu, there's a main section where it says text editor, and we preload XPSWM and STORM with Notepad++. It's the latest version of Notepad++, and we've also put that compare plugin to be available for you. So that compare plugin is new, and of course the update to the Notepad++ version. However, there are some other excellent third-party tools that you may want to consider. One that I use on my own version of XP is UltraEdit and UltraCompare. I suppose they are better than the Notepad++ in that they're a little bit faster, handle even larger files with ease, and can compare 3 files at once. Imagine comparing 3 text files at one time. So those are third-party tools which you could learn more about, purchase, and then simply make the edit here in the text editor, and so that you'll be able to go and use your other text editing tools that you maybe prefer. So that comparison, it's great. It puts things side by side. It highlights them in color, and there's even a navigation bar for all the things that are different, and there's buttons here that just hop to the next or previous difference in the files. Now for this sanitary or 1D modeling configuration in the software, it's under configuration, it says sanitary sewer refinements. The 2 choices are stormwater and wastewater sanitary. The stormwater one really means 1D, 2D stormwater modeling, and the latter means, like it says, wastewater or sanitary wouldn't have 2D, but so does some 1D stormwater only model. So perhaps there'll be a new slash here with 1D stormwater. It does several things, but one of the things it does is will compress the layer control panel and remove 2D items so that it's a lot less complex. You don't see all these other layers. Other tools on the toolbar become disabled or invisible so that there's less interface for the things that you're not going to be using. It also changes the units dialog. So the units dialog on the left would be for the stormwater case, but as soon as you go sanitary, wastewater, then we want to talk about the different flow units that you might be using. So as opposed to the default of cubic meters per second, you could have liters per second or liters per day or liters per minute as your flow unit, and then throughout the software you're going to be having reporting on those flow units rather than the default cubic meters per second. The modify elevations dialog was altered in that we added both match crowns case. Here's an example of the profile with the match crowns and a matched inverts case where we're matching the inverts. So you can toggle between those. Don't forget to be explicit in your choice of, are you going to modify the inverts of nodes and modify the inverts of links, because you could have these unchecked and it wouldn't make any change. As always, the modify elevations dialog works with a selection of objects first. So you select your objects, then you go to modify elevations, and you can make any of these changes, including these 2 new ones. It's really along the line of design. So perhaps you are sizing conduits in XP, because we can auto size the pipes, and then after they're auto sized you want to align the crowns or align the inverts, and that would do that. And then you could go into more of an analysis mode and check your design, see how it performs. So the profile plot, you can access this from the results menu, then profile plot, or it's tied also to the F8 key as a shortcut. The changes here is that we're allowing multiple plots per page, and also the ground elevations to be shown rather than a straight interpolated line between them. The profile plot then, once you've got the multiple pages, you can start moving around these on how you'd like to have them ordered and what scale you'd like to have for them. So not only did we, of course, create lots of enhancements or new features, but we also look and listen to our user base at our workshops and through our online tech support portal and the emails and the phone calls, etc. And we want to improve that user experience. So there was a pretty big set of things that we did. I'm not going to worry about this list. It's just a snapshot of some of the things, but it kind of gives you the scope of it. We make changes to dialogues in order for things to make sense better, and we fix things if they're not performing the way that we want them to. Really, the team has made hundreds of small but significant changes. I just like to highlight a few of them and some that are representative of the bulk of the changes. So here's one example. In the global storms, and the same thing could be said about the scenario manager, it's possible to assign a name. Well, in previous versions, you could have created a name which is not valid for a file name. And the global storms and the scenarios, their names get appended to the file name for the model results for each of those storms or scenarios. So now there's a check made in the global storms dialog and the scenarios, and we'll generate an error. We won't let you proceed with a name that's not going to work for you. So that's an example of improving that user experience. Another was the weir. So the hydraulic computation does not solve for the velocity of a weir. In previous versions, the velocity would show, but it would be 0 all the time. And so that's somewhat misleading, right? There wasn't a 0 velocity. We just didn't compute it. And so now when you go to the review results or the time series graphing for a weir, we just totally suppress the velocity. You can't show the velocity for the weir because it's not something that's being computed. The flow is the levels upstream and downstream, but not the weir velocity. Another example is we've changed some dialogues so that they can take faster data input. Previously, a user inflow time series, when pollutants were involved, would put every single value in its own unique cell. And this really wasn't conducive for copy and paste, since every cell would need a copy and a paste. So here I've got, 5 rows, 5 columns. You'd have to do 25 copy and pastes. Now we've changed this dialog so that it's a full grid, just like a spreadsheet view, if you will. And this could be copied and pasted, all 25 values at one time. So we've updated the dialog from separate items to a grid, allowing really fast copy and paste. We've changed some of the dialogues in some subtle ways, some not so subtle ways. For example, we've replaced several pictures. We plan to do more in the future, but we looked at the ones that were most common and the ones that were misleading, and we've updated them. You'll see some of this great artwork that the team's been doing. Not only have we done, say, something that's more pleasing, but also, remember, a picture's worth 1,000 words, so pictures that make more sense. We've also changed the text. So over here on the right, this is from the pump dialog. This used to say initial depth and then pump starts, pump stops. And many users did not know that these next two fields were actually elevation fields and not depth fields. And so we explicitly write now that it's a pump starts elevation value. This is the depth, these two are elevations. Another way which we are enhancing the product for better assimilation, I guess, or faster learning, if you will. The 2D land use dialog, in fact, was so big that when it was used on low resolution monitors, the OK and cancel buttons were off the screen. Now, that was only the case if you're using a monitor size that was less than the minimum requirement of XPSWM, but we noticed there are quite a few users on laptops with low resolution screens, and although you could always press OK or cancel or escape, the enter map to OK, the escape map to cancel, you could always close the dialog, but it was sort of annoying that the OK and cancel were off the screen. So we've shortened this dialog, we compressed it and so that everything could fit, and even if you were using less than the minimum spec of XPSWM, you could, or XPSTORM, you'd still be able to make those edits. We've also exposed some fields whenever it was appropriate. So for example, the 2016 dialog on the left versus the 2017 one, you'll notice perhaps that you can enter and visualize the invert elevation on this dialog. So it was not exposed in 2016, but it is now in version 2017. So this is another example of the maintenance. Well, my last main topic for my webinar is really a short discussion about model templates. So I used a template when I started my challenge, and the template essentially gave me things like model defaults, some global database records like RAIN or predefined XP tables, but it's basically an XP file. It's a typical XP database. It just has a T at the end, technically speaking. But the way that we use it is seed information for the next model. So anything that can be in an XPSWM or XPSTORM database can be a template. Now, I would say it's like the #1 thing for being very productive in our software. If you are doing the same kind of models, or you're doing models for the same general geographic place, or you're a large organization, you're going to be able to put in some things into a template that acts as a little bit of a standard. You could even take it down to the way that things are drawn. So for example, if you have drawings, if you have CAD drawing standards or GIS drawing standards that says, for example, that a park is a certain color or a certain color shading, etc., then you can use that same color definition for the polygons and the polylines in XP. If you are working for or making many models for the same location, let's just pick, I don't know, Newcastle. So you're going to make a lot of models in Newcastle. You could create one time a global database that had all of the Australian rainfall and runoff storm patterns. You could have the IFD curve. You could have the typical shapes. You could load it with the inlet rating curves. Everything that's in the global database, you're just going to be able to have it as seed information for your next model. So I would say the templates not only is a way to have a standard amongst the organization or the region, but it also helps model reviewers. So all the models are going to be delivered kind of the same way, with, let's say, green links when they are bioretention ditches or something like that, right? The blue nodes mean it's the combined sewer node, etc. So when you're reviewing, if you're always getting your information in the same way presented, it's easy for you to be able to judge the model's reasonableness and conformity, among other things. The software has default templates. So in your choice, you can, under the File menu, New, there is Use a Default Template. So we've created a US and a metric default template, US units and a metric default. So that's a great way to start. But you can override the software's default template. You could make your own default template. Again, that's in the INI file. And you would be able then to make that the default. Anytime someone did file create from default template, they'd be using the same one. any XP model that you have can be a template as well. You just do File, Save as Template. There's a templates folder that's part of the software install, and you can populate it from the XPSWM, XPSTORM Resource Center. Perhaps some of you are aware of it, or others may not be. But if you go to the website called help.xpsolutions.com and go to the XPSWM, XPSTORM Resource Center, there's a download section and there's some model templates. You can grab all the templates that we have by just clicking on this All Templates, download the file, unzip it. But you could get specific ones. For example, there's for Australia or Malaysia or New Zealand. You could just go and grab the templates that we have. Now these are templates that we've created, and we've created them based on stormwater manuals that we've looked at, or based on some cooperation that we've had with various clients. However, when we created the Resource Center, we envisioned that the Resource Center would, because it's a wiki, that we would allow external contributors. And it's been on my mind, and I guess I would like to ask those of you that are on the webinar, you know, what's your opinion about this? Maybe we could have a short poll, but would you be willing to provide templates for the kinds of models that you do, or the region or the area that you work in? Is that something that you would want to be able to do and share? Well, thanks for that. That really is about the end of my presentation, but maybe I'll get Sophia to take over here.
Thanks a lot for all your information there, Tony. It was very beneficial. And if I could just hold on to you for a couple more minutes, I know you're really eager to get into your golf games, or actually probably go to bed at this time of day. But just some upcoming training around Australia. If you're interested in learning more or getting to know the software, maybe updating your skills, come and spend 3 days with me. We've coming to Brisbane, Sydney and Perth. Places do fill out, so get online or send us an email and make sure you register. And just an update, there's been a lot of people calling in and asking about the ARNR 2016 software updates. We are just as keen as you are to get that in the software. We're working on it right now. The biggest focus will be working on getting those ensembles, generating the storms automatically for you. Tony's already gone through the Solve Manager, so that will make solving those hundreds of storms a lot easier and a lot quicker, but that will be coming in autumn, and that's autumn in Australia. And that pretty much concludes our webinar for today. Thanks a lot for joining us, and until next time.